Thank you very much for giving the opportunity for this talk. I'm going to talk about the dark matter search at Belle and Belle II. And Belle and Belle II is a flavor physics experiment at KEK with 3-kilometer accelerator of E plus E minus collider. And this is basically for flavor physics and called B factory experiments, so produce large number of B mesons for CP study of CP violation or search for new physics. Okay, so this can be also used for dark matter search, but so far this Belle for 10 years operation, we accumulated 1,000 inverse femtobarn of data, and this new Belle II experiment is now running in operation, although it's under COVID situation, and we accumulated something like 200 inverse femtobarn, which is still smaller than Belle, but our final goal is something like accumulate 50 inverse attobarn. And the peak luminosity is already exceeded the previous one and world record, but this also needs to be increased by factor of 10. Okay, so as I said, this Belle and Belle II can also use for dark matter search, but this CM energy is 10 GB. So in principle, we can search for the mass region up to a few GB or sub-GB. And basically, we are looking for some process with, some standard model particles and mediators. These mediators, which has some interaction between dark matters and connect dark matter and standard model, and we have many kind of candidates. And we see something like this E plus E minus collision goes to this some standard particles to mediator, or some B mesons decays to standard model particles mediators. And in some cases, this like dark photon or Z prime explains the discrepancy of G minus 2 anomaly, for example. So this is also quite interesting in terms of flavor physics. So let me show a few results from Belle and Belle II, which is already published. So one is this search for Z prime photophilic, so this new light neutral gauge Z prime boson that couples to mu tau leptons, mu or tau leptons. And well, in this Belle II search, we search for Z prime goes to invisible case, like this kind of diagram. And for this analysis, the analysis was done with very small amount of data taken at the commissioning run on 0.3 inverse femtobarn. But we already get some limit to this model. And in Belle II, we search this mode, and basically we look for some bump, but we don't see anything at this moment. And we have some limits on that coupling chip. And okay, so it's still far from the some region or band that can explain G minus 2 to explain this G minus 2 discrepancy between theory and experiment. But okay, if we have something like 100 inverse femtobarn, we may reach to this band. And actually, we already have this amount of data, and the analysis is going on. Another search bit, this Z prime goes to mu plus mu minus is done by Belle. So the search mode is E plus E minus goes to mu plus mu minus Z prime, and Z prime goes to mu plus mu minus. So basically, for muon final state and look for this invariant mass of this mu plus mu minus. And we have many background processes that have 4 muon final state or some particle fake to muons. So we need to, understanding with this background processes. But you see this middle plot, and this disk. That shape is rather well understood. There is discrepancy between data and Monte Carlo, but this is due to IS initial state radiations. And for this one, we also search for some bump, but we don't find any bump. So we set some upper limit, which is similar to a limit as Babar experiment. But anyway, yeah, we get this result. And this kind of analysis also going on at Belle II. Although we have still small amount of data, we think we get similar sensitivity. Let me also introduce some different kind of searches. One is, search for B mesogenesis. So this mesogenesis is, explains this baryogenesis and dark matter with B decays. It's a theory. And with this kind of theory, we have, rather robust predictions that B mesons decays to lambda to some dark sector anti-baryon and meson. And the branching fraction is something like 10 to minus 4. And we have experimental limit, the mass limit from LHC, and also upper limit from RF. But Belle searched this decay with full data set of Belle. And the strategy is really, from E plus E minus collision, we have a pair of B mesons, and one B meson is reconstructed with hadronic mode. And for the other side, we reconstruct lambda, and we look at remaining energy of in the event. And if this event exists, we should see some peak at this ECL remaining energy at 0. But as you can see here, this is basically consistent with background. And we don't see any signal for this decay. So we set upper limit of this B0 decays to lambda and this anti-baryon, dark sector baryon to order of something like 10 to minus fifth. And okay, the prediction of this B mesogenesis is larger than 10.5, but this is for the decay B0 to lambda plus this dark sector anti-baryon plus some meson. So at this moment, this doesn't directly exclude this model, but we have some prediction of this lambda psi ds, and if you see this our limit and some kind of prediction, then it's we are coming to very close to the region of these models. Okay, and for the last one, let me say a few words on the ongoing analysis at Belle. So this is a kind of basic mode for the dark matter search at E plus E minus colliders, which means E plus E minus goes to just one photon and the rest goes invisible. So it's basically looking for some dark photon. And the difficult thing of this analysis is that the final state is just one photon, single photon only. And we see, try to find a recoil mass for on the bump, try to find a bump on the recoil mass or look at some peak of this photon energy. And because of this single photon trigger, we need some special single photon triggers to correct such events. And in case of Belle experiment, we didn't have such trigger. So at Belle, we cannot do this kind of analysis. And similar experiment, Babar had it for some period from some period, not all the period, and they have this kind of upper limit. And now, Belle II, we are quite interested of this mode. So we have large effort to have this kind of trigger and also improve the triggers. Also, we need to understand the detector because we have large background from E plus E minus to gamma gamma. So this analysis is ongoing, and we have, it's not a problem statistics, but we still need more understanding. So it's ongoing. So finally, this is my summary. So I just introduced a few analyses from Belle and Belle II experiment, but there are more results from Belle and Belle II, which is already published, and also many are ongoing. So, and also with more data coming from Belle II, we will see more results. So please stay tuned. And thank you for your attention.